Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so that you can help your kids with math. So today we're talking about the commutative property of multiplication. And John, my understanding is that they start covering this in elementary school. So basically, the commutative property states that the order of the numbers in the problem can be changed without making without impacting the answer at all. So we all know that 2 times 5 is going to give us 10. And then if I were to change the order and say, what about 5 times 2? That would also give us 10 because multiplication is commutative. John, can you kind of explain the reasoning behind that, why that is?
Sure. So many students in secondary school and even adults just kind of know that if I do 2 times 5 or 5 times 2, of course I would get the same thing. But for younger students, that's a much harder concept to understand. So usually we show them through arrays, giving them a visual so that we can convince them that multiplication is indeed commutative. We could take something like 3 times 6 and represent it as an array. Recall, an array just means an arrangement. We're writing it out as a row by column. So something like 3 times 6 in an array form would mean that we're doing 3 rows of 6. So as you see over here, I have 1, 2, 3, 4, 5, 6. And because there's 3 of them, I can either continue counting, through the answer, or we can just multiply, the 6 by 3 and get 18 that way. And if I just rearrange the array, if I think of it as, if I think of maybe turning it through a rotation or just looking at it as 6 rows and 3 columns, I can pretty much count in the same way. So if I count this way, here are my exact same 6, but now it's vertical. And then I have 3 copies of that in total, 2 additional beyond the first one. So once again, if I added these all up, I would have 18 altogether. Multiplication is commutative, just like addition.
Great. What I really like about using an array is it also just reinforces the connection between multiplication and addition. Like, kind of, it reinforces what multiplication is. So for this array, you're literally saying, look, there's 3 of these 6 times.
Correct.
And here you're saying, okay, there's going to be 6 of these 3 times. So it helps develop intuition in terms of both the multiplication and the commutative nature of it.
Exactly. And in all of our videos, we've been talking about how these very elementary ideas travel up the math continuum. And here's another one where when students work with matrices, they look at things in a row by column type of approach. And they also revisit commutativity there. When we talk about matrices, commutativity in multiplication doesn't always happen for reasons which are beyond the scope of this video. But planting the seeds early helps students understand why it does work when it does and why it doesn't work when it doesn't.
All right, well, I'm excited for us to do some problems.
All right, let's go to the next slide.
Okay, so I'm going to tackle the problems on the left, write an equation for each array. So I'm just going to take a look at each one, and looking at the first one, I can see I've got 4 rows and 5 columns. So this equation is going to be 4 times 5. The array on the bottom, you can see now I've got 5 rows and 4 columns. So this one is going to be 5 times 4. And this just again illustrates how multiplication is commutative, because either way I have basically 20 objects in the array, because 4 times 5 is 20 and 5 times 4 is 20. So multiplication is commutative. John, I see that we are going to tackle a word problem next.
Yes, we have a lot of math shirts here. If I have a dresser with 4 drawers, and if each of those contains 5 math shirts, while you have a bigger dresser, you have 5 drawers, and each of them contains 4 math t-shirts. Would we both have the same number of t-shirts? And based on what you're saying, it looks like we would, because if I only have 4 dresser drawers, then I'm gonna have to have more in them to have the same amount as you because you have more. So you would, it would be okay for you to have fewer shirts in each drawer because you have more dresser drawers. It's the same exact thinking. Like I would have 5 in each of my 4 drawers for a total of 20, whereas you would have 4 in each of your 5 drawers for a total of 20 as well.
So it's just kind of a real world problem illustrating the commutative property. And, sometimes word problems can be a little unrealistic, but I think this one's pretty much spot on. I think we would both be quite happy with 20 math t-shirts each.
Absolutely. I think I have close to 20, actually.
We'll have to wear some for our next videos.
Yeah. And then also, I think another concept that's worth reinforcing is equations. Again, equations might seem like something students don't do until later, but they actually see them a lot earlier on than you would think. They do see them in elementary school. And while they might not have variables like n or x, students are exposed to the concept of equations through number sentences. They get, one statement on one side and one statement on another, and we want to make sure that both sides are equivalent, like a balance scale. So if I have something like 4 times 8, I want to know what would I need to fill in the blank with to make both sides the same, or to have the same number of math shirts on both sides. So if I had this 4 drawer dresser with 8 math shirts in it, how many shirts would need to go in each drawer if now I had this monster tall 8 dresser drawer dresser? So that would have to be 4 as well, because the multiplication is commutative. 4 rows, 8 columns is the same thing as 8 rows, 4 columns. And then also, if I look at it another way, if I have a 6 drawer dresser piece of furniture, my drawing is not so great, but let's say I have this really tall dresser drawer and there's only 1 shirt in each, very lonely drawers. Another way I could also do this is I could just have a single a horizontal dresser with 1 row, and then I could have 6 drawers this way. And then in each one of these, I would have 1 shirt as well. So that would also give me out 6 shirts in total to maintain the equality.
Wonderful. Excellent. I really, I'm enjoying doing kind of a deep dive into this. It's so much more helpful to really understand, why something is commutative and what that means, rather than just memorizing, oh, that means A times B equals B times A, which can also be helpful, but to kind of have ways to apply it, to have some visuals, I think can really help it sink in and make connections to other areas in math.
Absolutely. And that's one of the common core math practices that students want to be able to experience math through multiple representations. So having them work with arrays and word problems and number sentences just makes everything more coherent for them as they move up the ladder.
Excellent. Also helps them recognize math in real life too.
Next time
they're arranging their t-shirts, maybe they'll think of us. Well, thank you so much for watching. This is Math Videos for Parents. Please subscribe to our channel on YouTube. It helps other people find us. And we're also on Facebook. And don't hesitate to reach out to us if you have a problem. We'd love to help you work through a math problem that you're working on. Thank you.
Thank you. Have a great day.